The activity opens with a figural pattern displaying in the pattern player, and it appears in random order. So we're seeing different particular cases of the pattern playing on a loop. If I pause the video, I can step back or forward through the pattern. Now, the task objective for the students is to recreate the appearance of the figural pattern in the designer's grid and build associated expressions so that they can come up with an expression for the total number of lights is the context for this particular activity, so we're referring to these as lights, to build that particular pattern for any figure number. So I'll start by recreating what I think the tops of the trees look like. And part of the instrumentation in this particular software is to learn that when I think I've built the building block for a pattern, I need to define it as a block and, in the words of the students, pattern it, so that in this particular case I've got a default number of 4 blocks, and I can actually go into this cell here and change to another particular number of blocks. The students are expected to make sense of this line in the expression builder and, using drag and drop functionality, create an expression for the number of lights when, in this particular case, we have 5 blocks. And you notice some feedback there that suggests that I have a correct expression if I were to change my number of blocks to a different number, so my software will update. Now, the next part is actually fundamental to the software design in terms of building the general case. You'll notice a padlock symbol next to the number 2 here. If I select it, a pop-up window appears with a very enticing Alice in Wonderland style text, "Name me." And obviously the students are very informal in their naming. I'm going to replicate a very popular name for a variable in our Key Stage 3 classrooms in the project, Bob. And what's different now is Bob comes with a slider, so I really have got the idea that my number is now unlocked and it's actually free to move within the domain, which is integer values of Bob from 1 to 10. Now, having done that, I'm going to continue with my pattern and work on the trunks. And similar idea, I think that's the building block. And then if I define my pattern, again I get default of 4. Not quite right, plug it into place. And down on my expression builder, again I can build an expression for the total number of lights for the orange trunks of my tree. And as before, I can name my variable. So I've got Fred and Bob, and I can of course make Fred and Bob be the same, but what's happening here is you can see Fred and Bob are different names, they're different variables, therefore they behave differently. Now, the expression for total is thinking about the total number of lights for a given pattern. So if I do what lots of students would do at this stage and make them look the same, because we're okay with that, we can justify that they need to be the same. And if I want to create an expression for the total number of lights in the complete pattern, then it's thinking about the operation I would need to do in here, which is a total. So I'm going to use the operation addition But it's still a bit dissatisfying. Now it's interesting, in the classroom students don't necessarily think that, but that's part of the teacher's role to prompt that. How can we make it so that the way that Bob behaves and the way that Fred behaves is in sync, or together, or this sense of the dynamic variable, they need to be the same always. So, key to that, if I need them to behave in the same way, I need to give them the same name. And at this stage, students are prompted to really think about what they're doing here, and there's a key word on the screen, link. And the process of linking those variables means I have a link sign down here, so I can see that Bob is my dependent variable to which this Bob is linked. And over my pattern player, you may have noticed that I've got brightly coloured lights. So as far as the landmarks here, we had the process of naming the variable, we had the process of unlocking, which was essential in order to do that, and the process of linking the variables, which in the sense of the dynamic environment we're working in here is a key idea, and obviously a key way in which students can see the power of variable as a mathematical idea.